Practice problem number 3. So working with sample problem 3-4, Avogadro's number. How many atoms of aluminum, Al, are in 2.75 moles of aluminum? Okay, so we've been given by the question 2.75 moles of aluminum. I'm going to convert. Now, I'm going to have to go out of moles, so that tells me that I need to put moles as the unit on the denominator, so that when I divide moles by moles, they'll go away. And the unit that I'm being asked for is atoms, right? How many atoms of aluminum? So hopefully you can see that when I actually do my calculation, moles will cancel. And the only unit I'll have is atoms of aluminum. Well, good old question. How do I know what numbers to put here? Well, what's your statement of equality? 1 mole of aluminum is equal to 6.022 times 10 to the 23rd atoms of aluminum. So what number do I put in front of moles? Whatever number I have in front of moles over here. What number do I put in front of atoms? Whatever number I have in front of atoms over here. And now that I've set this up correctly, again, using units first, this tells me to go and multiply 2.75 by 6.022, then divide by 1. Let's see, should I use 3 significant figures? So 3 significant figures would give me right? Yeah. But did I do anything with this right here? No, so it's still there. And check this out. There's no exponent over here. There's no exponent over here. So it's like nothing plus 23, 23 minus nothing. So it just stays times 10 to the 23rd atoms. But this is not appropriate scientific notation. I'm going to have to move the decimal 1 time. So I have 1.66 times 10 to the something power of atoms. Well, again, I went from a 16 down to a 1.6. So did this number get bigger or smaller? It got smaller. So in order to balance that out, this number needs to get bigger by 1. Because remember, I'm not allowed to change the value of that expression. All I can do is change the way I represent that information. That is it. And so if one part of the term that's in scientific notation is made smaller because I had to move the decimal that way, then I'm going to have to change the exponent to balance that change and make it larger so that the overall value stays the same. So, practice problem number 3. Correct answer is 1.66 times 10 to the 24th atoms of aluminum.